All right, good morning and happy Tuesday. I'm planning on doing the LeetCode Daily Challenge for today. It's July 11th, and it is 9:29 a.m. Hide that here. Okay, so day 11 here. All nodes, k distance, and binary tree. Any order. Distance 2 from the target node with value 5, 1, 7, and 4. Okay. Alrighty, so we should be able to just go to the target node and then BFFs outwards from there. So that'll be the game plan. Okay, it is 9:30 in the AM. The game plan is DFS to find the target node T. Then, oops, let's do this. To BFS from target node to K. All right, so that's a game plan. And here we go. Let's do this. TK. Yeah, go. Node equals root. If node equals the target, then we'll return node. So we want. Otherwise, we'll go to the left and the right. If node yeah, it's not trying. It's a base case. We the other left or right subtree or the root itself. Okay, and then the BFS node equals go. Right, so there's our target. And then we'll return BFS. All right, so the result will be the array we return, which is k distance away from target T. Right? Or start. It's called start. Results will be built off of a queue. Right. So we need to keep track of parent pointers in. Or if we're going to BFS, got to keep track of parent pointers and then traverse the whole thing. So I want to traverse the entire tree because we have to create parent pointer. So that's basically where I'm changing this. So the parent of each tree node will just be a map. Okay, so our base case if node is equal to t, then start equals. Wait a minute, hold on. Oh, here, this is already given to us. Okay, we don't need to go find it. Oops. Okay, I misread that. Okay, so never mind. Here, never mind that part. That's already done for us. Oops. Right, okay, so we just need to go still find the parent of each values, right? So last node we'll keep track of. Okay, so parent of this node equals last, and then go not node, but just return go node dot left, go node dot right, and then last will be this node. Okay, so that's that. Okay, so just invoke go here. GFS, we already have start, which will just stick here. Key. So we have parents where we can go outwards, right? For each kid's depth, so far, range, length of Q. Check what we've seen. Parent equals the parent of node is Q dot top left. P is the parent of this node. So if there's not in the scene, add on to it, right? So Q dot parent of this node. So let's just do this for next in this list, right? This guy should be the parent, and then the left and right child. Let's be the next node. Okay, so if next is not in the scene, append next. Okay, so these are the adjacent nodes. Okay, yeah, I think that works, right? So when do we add it to the result though? So we'll go to the kth depth. So k is 2, go k is 0, k is 1. Okay, here k is 2. I'll break out. And the q is what we want to return actually. Right, so return the q, whatever's on the q at that depth. Okay, so here we go. See what happens. 930. Uh-oh. Check not implemented. What? Oh, I'm gonna try this less. Well, that didn't work. 0 and 8 are also there. But is right. Deeper. 5 is 0. 3, 6, and 2. K is 1. Here's 7, 4, and 1. K is 2. What's next? For the entire. I think that dynamically changes. This is the whole thing. This is weird though. The queue is like an array of arrays. The output is a list of. I guess we want to spread it, right? List of queue. All right, that's just weird. That just print out what's going on, I guess. You, this guy. K is this guy. Okay. Next, we add onto the queue. Okay, let's see what happens here. Okay, so go, these are parents. Holy cow, this is gonna be hard to read. Let's just do, all the values are unique. Let's just do, we're going to take a debugging. All right, Q will be that value for node in the queue. Okay. Next, just the value. Print. Oh, okay. If next and next is not in the same node, next has to be something of the none parent. Okay. 108. This is weird. How do I get 108? 0, 1. Next. And how am I getting 108 at today in here? That's weird. I'd expect the next to be printed as 0 and 8 if it was even added to the queue. That's just weird. How is 0 and 8 getting on here? What the heck? It's in the key. Wait, is it? Am I supposed to return a list of integers? Oh, okay, so it is the value. There's that value for node and queue. Okay, maybe that's why. Okay, that looks good. What the heck is going on? Okay, let's run it for the example test cases. And then I don't need to print anything. This should be okay. And then I'm pretty sure I can just remove this. I don't need that temporary. Okay, get rid of my prints, and then I'm pretty sure this is good, right? 9:44. So it's about 14 minutes. Okay, let's see what happens. Looks like I solved this 5 years ago. Yeah, almost 5 years ago exactly. Okay, that's cool. So I did it in C++ 5 years ago. And this is for the implementation in Python 3. Oops, Python 3, which is accepted. Yay. Right, so do DFS to go find all the parents, and then BFS from our start. As for start, right? It's start or source. Okay, and that looks good. All right, that's cool. And then let's see if I posted something previously, and then I'm gonna solve this in the other languages here real quick. Okay. Yeah. So and kind of the same thing, right? This is ugly. Yeah. Yeah. So complexity is not intelligent, right? Simplicity is intelligent, and this can be simplified. So that's what I'm going to do, right? So keep it super simple. The less code rewrite, the more concise and self-documented it is. Like the easier it is to read, write, and understand. So that's what I'm aiming for, is to help myself and help others, right? To see like clear and concise explanation as like a recipe in code that's self-documented. It makes like some kind of cohesive sense, hopefully. We'll see. I think it's good practice. In worst case, if it's not helpful for others, and I hope it is. I want to make these variable names pretty clear, right? This is a node, this is the next node, which is either the parent or the node's children, left or right, right? So DFS and BFS. DFS, we just recursively go, right? So one recursively go find parents of each node. I guess traverse the tree, tracking parents P of each node. To perform BFS. I guess BFS source. From the K. Turn the K. That's list of node values. Okay, that sounds good. Now recursively go traverse a tree, tracking the parent P of each node, and perform BFS starting at source, right, from source, right? Okay. Yeah, I mean it's a pretty decent solution, I think. Yeah, my other solutions were pretty ugly, I think. All right, so let's do this again. It is 9:49 a.m. Just do it best here. All right, so here's a vector. Just clean this up a little bit. Sure, integers is what we'll return at the end here. Here's our source. Going to be our function, which will be our recursive lambda. You don't need to return anything. We just need to find parent tree node pointers. Go capture yourself in your own lambda node and last. If node is null, we'll just return. Otherwise, the parent, which would be a map, so it's got map parents. Parent of this node will be last node. Go node left. Node is that one's last. So that one. Okay, so invoke go on root, the node's parent, and then BFS will be a lambda. Capture the parent mapping. Turn BFS. Okay, and use a queue. Oops. Here. Here. And scene will be a set. There's scene. Source. Now, q.size and k minus minus. Actually, I'm thinking maybe I want to clean that up a little bit. Let's just do this instead of having k as an additional variable. Let's just decrement k. Right. Make it a little bit more simple. A reference is this guy, right? Oh, let's do this. Yeah. Non-local. Okay. Okay. So that is a little bit ugly. I guess. Pass that thing in. Eh. Whatever. I kind of like that more than incrementing k. All right, well, C++ can capture it a little bit more cleanly. Okay, and then we're going to kind of return this vector of the Q. Oops. So Q dot size, result of pushback, Q dot front. Instead of the Q then like that, because that's ugly, right? I just want to return the Q like this using the initializer. This, so the Q will then be a deck. Okay. Q will be a deck. U dot front. U dot pop front. For next in list. Let's do this using node equals tree node pointer. Just to clean these up. This is really ugly. All right, let's remove these. Usually in a text editor, I guess I'd do find and replace. We'll get there. That works. Using nodes as a vector node nodes. Let's make this self-documented, right? Okay, so P sub node left, right, if next, and scene that insert next second. So scene is a set, an owner set. When we invoke insert returns a pair. The first of the pair is the iterator to the inserted element. Either it's a new element or an existing element. And second is a Boolean value indicating whether or not the value was actually inserted. So it's true if it was inserted, false if it already exists. Okay, so we're looking for if it is inserted, right? So in that case, you want to say, okay, q dot push back next. Okay, and let's do this actually. Int, we want it to be less than 0 eventually. Let's just do n, lowercase n, now n minus minus. So let's do this. Okay, and I think that'll work. 956. Okay, range is really? Come on. What is going on here? Oh, oops, I need to transform it into a vector of integers. Oops, okay. Dang, okay. Transform. If this works, yeah, this should work on the back deck. Yeah, okay. So back insert result node turn the node's value. Oops. Okay, that should do it. Okay, and then this is 957. Here we go. Okay, big money won't know Amy's. Big money, big money. Okay, cool. And this is awesome. Yeah, this is like way better than my previous solution, I think. So actually, let me just undo this here real quick, just so we can look at the previous solutions, and then I'll redo it real quick. So it's two-part explanation, pretty basic, right? Pretty straightforward. Previously, it's just like, holy cow, I was like, what is this? There's no white space. Like, that kind of sucks. Okay, some of the explanation is pretty obvious and straightforward. Yeah. It's just overly complicated, I think, and just kind of ugly. Right? The white space sucks. Yeah, okay, well. Back to all this stuff that I wrote. Okay. And yeah, this is like way better. Simplicity, not complexity, is intelligent, I think. Okay. But that's just me. What do I know, right? I still have a lot to learn, but this is something that I can understand, right? So I like to keep it super simple so I don't get confused. Okay, I'm gonna go grab some water real quick from kombucha, and then I'm gonna do this in Kotlin, JavaScript, and then I'll call it a day. I'll be right back. Okay. All right, let's jam on this in Kotlin, JavaScript. Here we go. All right, it is 10, it's 10 a.m. even, and it's time to shine. Here's our source. Okay. By that, so we'll just do this. And then, yeah, so the game plan will be the same, right? So do function go, node is a tree node, it's root, and then last is a tree node, sliced at null. It's going to return nothing. We want to populate parents as a mutable map. Tree node. Let's do this actually. Type alias node equals tree node. That just to shorten this up a little bit. Get really old typing that in over and over again. Node. Parents. Okay, so if node is null, just return here. Otherwise, the parent of this node is the last node. Seemed our traversal. Nodes left. This node. Node to right. This node. All right, so go. And then next we'll do BFS. BFS. So return our list of integers. S. Okay, depth. Let's do this. Well, yeah, I don't know, whatever. Let's stick it there. Okay, so our queue is a queue interface of a tree node. Oops, node. Called node. Equals a linked list, the underlying implementation using a node and a list of our source index. And then let's do this. Queue and scene pair mutable set of foods, which have been seen. Start S. So while unit size exceeds 0 and A also exceeds 0. Keep the def and then return the queue. Get it out of the queue. Hold on. And queue. It's an interface, right? So pop them all off. This integers. Values what we want. Okay, something like that. Uh-oh. Pull. Oh, oops. If next does not equal null. Okay, that looks good. 10:05. All right, cool. 5 minutes for the implementation in Kotlin, which is accepted. Yay. There's Kotlin. I wonder, actually, yeah, that's really ugly. The way that it's formulating the result here. It should be able to be cleaned out up, right? Is there a double-ended queue? Like a vec, I don't know, ended queue in Kotlin. VecDeck or something, RayDeck? Okay, use RayDeck. Let's do this. Turn q.toList is an array deck, which should be some mutable collection, right? Array deck. Let's look at array deck. The constructor looks like. Oh, this is a collection. Okay. Let's do this. Oops, array deck. Array deck. That should work, I think. Oh, to list. Oh, okay. Q.map. It value to list. Actually, maybe that already is a list. I don't know. Do I need to invoke toList? Yeah, that's cool. Okay. Yeah, that's a better solution. It's kind of ugly, so it's nice to clean it up a little bit. Right. Yep, okay. It's a decent solution. Looks cool. Okay. Let's do this in JavaScript and I'll call it a day. It is 10:08. Oops. In the AM. Okie dokie. Root or source. And okay. Let go. Let's do this. P. It's a new map. Node is root. Oops. Last is null. If the node is null, p dot set the node to last. Go node left. Node right. Node. Okay, and then let's go. Book that guy, and then let's BFS. Function we can invoke here. All right, so Q, this guy, scene, be a new set. Turn data value. Oops, hold on. Student map to its value. Well, use length and k minus minus. Q dot length n minus minus, right? So one q length at a time. Q dot shift. And this might be a quadratic shift depending on the unwilling implementation. Let's explore the next parent of this node. About left or about right. If next and scene does not have next, then q dot push next. Scene to add next. Right, okay. Something like that. 1008 to 10. Oops. Scope equals that guy. Syntax error. 10, 11. 3 minutes. Awesome. 3 minutes for the implementation in JavaScript, which is accepted here. Okay, and that's it. That's all she wrote for today. Yeah, I can't get around C++ transformation, right? Okay, and here, this is it. Recursively go traverse a tree, tracking the parent to P of each node, and then perform BFS from the source S, and return the kth list of node values. Oh, I didn't do Rust. I guess, yeah, I'll do that later, maybe. I don't know. Rust is kind of a pain. Yeah. It's just too strict, I think, for what I'm trying to do here, right? It just really clouds up the algorithm in that it's just very verbose. Yeah. Okay. Anyhow, I'll catch you all later.